Okay. Yeah. Okay. Yes. Hi. My name is Tomi Männikkö, and I'm from Nokia, and I'm from the airframe R&D. So I've been working with this openEDGE chassis for a couple of years now. So and that one we have contributed 1 year ago, and okay, now we are seeing some results this year. There are plenty of new server sleds being done, and PSUs, BBUs available for the chassis. Okay, so today I will be talking about the RMC, which is the rack management controller for this chassis. But maybe first a short introduction to the chassis itself. So it's a 3U high chassis, 19-inch mechanics compatible. The depth is only 430 millimeters, so it's quite compact and can be fitted into a 600 millimeter deep rack. We are supporting 1U and 2U sleds, half width, and power supply is redundant. Power feed capacity is 2 kilowatts, and that's the dimensioning of the power feed maximum. We are supporting AC and DC inputs, and the power capacity for the sleds is 400 watts per sled. Per 1U sled, 700 watts for the 2U sled. This is just the power feed capacity, and typically the server power consumption is much less. And then there's the rack management controller, which is mostly doing power supply management, and in addition it provides Ethernet connection to all the sleds. And power is distributed via the backplane, and all the management Ethernet connectivity is done through the backplane also. Okay, so the main functions of the RMC are, first of all, PSU management. So the RMC is capable of reading the health status of the PSUs, read any sensor values, current, voltage, power, all that in a centralized manner, and controlling the PSU when needed to put it into a standby mode or something similar. Then the RMC does the required firmware updates for itself, of course, and then it can update the PSU's firmware via the connectivity it has through the power distribution board. And then there's the switch. I'll come into that a bit later, but we have a switch on the RMC board that is providing that connectivity to all the BMCs in the system. And well, there's the ID button, the last bullet there. By pressing that ID button, it is possible to identify this particular unit to a hardware management system. So for any kind of maintenance actions to be done there. And here's the block diagram. So basically, the RMC is a BMC based on AST 2520. So it's a pretty typical BMC implementation all in all. And so we have some flash there and DDR4 memory, and then we have that's a Broadcom switch, unmanaged layer 2 switch for the management, and external interfaces are one of the main functions for the switch is to be able to connect to all the sleds in the system via just one single port, and that makes it quite convenient to do the hardware management connectivity in a larger scale systems, reducing the number of ports needed. And yeah, power consumption is 5 to 10 watts roughly, and there's no fan needed for this unit. There are SFP Plus connectors in the front, and also for convenience, there's also an RJ45 1 gigabit per second interface to be used in systems that don't have a SFP connectivity. So using an RJ45 LAN cable, we can do the connectivity. And the two SFP Plus ports are there to provide optical interfaces when needed, and also to do chaining of the connectivity from one box to the next one. That's an option too. Okay, so this picture is showing the I/O or connectivity to the sleds. So 1000 base T interface to all the sleds. Then we have 3 GPIO signals, and they are currently used to identify the status of the PSUs towards the sleds. So in case there are problems with the PSUs, the sleds will know that. And they also indicate the airflow of the PSUs to the sleds, because in this system we can support cooling airflow from front to rear or from rear to front. So, and there are specific PSUs that have the airflow direction either way. And in the sleds, the fan units can be rotated 180 degrees to reverse the airflow. And in order to keep those in sync, so we have this kind of communication via the general purpose I/O, so that the sleds know that they are know that what is the airflow direction of the PSUs, and they can then raise perhaps an alarm that these are not aligned. And there's an SM bus for communication from RMC to BMCs for any future use. And RMC alert signal is to again to highlight a possible issue in the PSUs towards the sleds. For example, some kind of environmental condition that is requiring the sleds to maybe throttle a bit in order to reduce power consumption. And sled presence info to RMC. RMC knows which sleds are there. And then also the RMC will know when the BMCs are ready on the sleds. So this kind of general purpose I/O is being supported there. And here's the connectivity or interfaces towards the PSUs. The RMC is powered up by the standby 12 volts from the PSUs, and PSUs report power OK to the RMC. That's a hardware signal also. And SM bus for all the communication between RMC and the PSUs. For reading sensors and any health status reporting is done via that bus. and then there's the alert signal from PSUs to RMC, it acting as an interrupt to notify the RMC in case of there are any issues. And this is just a picture to show how much simpler connectivity can be made with the one single connection in the front panel of the RMC. So the yellow lines are showing the chassis internal hardware management connectivity, and the red one is the external one. And this example is just showing that if there's a switch or dual switches, just using a single breakout cable, the switch can connect to all the RMCs for a full connectivity to the whole system. So only a couple of wires are needed. And in this example, we have been able to eliminate the hardware management switch itself totally. So we are doing this in our racks. Okay, so this slide is showing the hardware and software stack of the RMC. This is showing our software stack, so Nokia software stack. We are using Redfish to do the connectivity to the hardware items below in the gray boxes. But this could be as well replaced by openRMC implementation, which is actually ongoing in OCP currently. So there's a project, a sub-project under the hardware management project that is building an openRMC implementation on top of the openEDGE server RMC. And then this slide is just repeating the environmental specs that we have for this openEDGE server product. So operating temperature range is extended from the typical data center hardware operating temperature range from -5 to +45 is the normal operating temperature range. And then in addition, we are also complying with the NEP's extended, the exceptional short-term temperature range up to +55. And then, we are fulfilling all the EMC specs and safety. The openEDGE server has been tested for Zone 4 earthquake compliancy, and acoustic noise, fire resistance specs are coming from the NEP's set of customer requirements, and these are actually today seen quite important still by the telco customers. And some product info. This is the whole openEDGE server has been in production since beginning of this year, and there's the link to our product. And we have a plan to contribute this RMC design also to Open Compute project as an accepted product, so meaning we will be providing the design files together with that contribution. We are planning on doing it still during this year. And yeah, the wiki pages are well, the project page is that can be found under the Telco project, and there are wiki pages then under that. There's a sub-project for openEDGE, and you can see the links here. And then I also added the OpenRMC links on the bottom. That was all for the RMC. Any questions?
It's a question about security and the secure protocol stacks that you have shown us before. Is it, do you use vendor-specific certificate in your firmware, and can we modify it or change it as a customer?
You are talking about firmware?
Yeah, I don't know. I assume that there is a kind of certificate to be configured in the system. I wonder if it's within your firmware. Is it a vendor-specific certificate, or we can configure it on our side or replace it after?
Well, I don't think I'm able to answer that. Sorry about that. Yeah,
no problem.
I'm a hardware guy, so it's a bit out of my scope. But
anybody else? Any questions? Oh.
Yeah, I would like to know why you would define two kind of the management port. One is RJ45 and the other is dual SFP plus for the management.
Yeah, so SFP Plus enables optical connectivity in case you have this server in a remote place. You can connect via optical interface then, and two, because you can do chaining from box to box, and the RJ45 is there for additional convenience in case there's a side router nearby, which is only supporting 1 gig RJ45 connectivity, which is quite a typical case. So it's there for convenience.
Also consider the case where you might have an operator show up at a remote site and need to plug in and analyze. Right?
Yeah.
Easily do that with his laptop and not have to tie into the switch.
Yes.
RJ45?
Yeah, it's on your laptop.
You mentioned the short-term operating temperature, which is 55 degrees.
Yes.
Is there how is it different between short-term and the regular 45?
Well, it's how it's defined. So it is a NEPS environmental requirement, and they have specified it as a short term. So it's a certain amount of hours per year, certain amount of consecutive hours. So it's a kind of a failure of air conditioning system in a site that is covering that it is covering typically. So short term in that sense.
So just follow the NEP.
Yeah. We are fully NEPS compliant with this system.
Any other questions? Okay, Tomi, thank you.
Okay, thanks.